Hello everybody, my name is Arul Kolla. I'm a 2023 Caroline D. Bradley Scholar, and this is the third video in a series of IEA virtual learning labs about creative problem solving. And today I'm going to be talking about working backwards. So before we get into that, I just want to give a brief review of what creative problem solving is, just in case you haven't been here before. So it seems that everyone's always talking about creative problem solving. You see people always saying that it's like one of those 21st century skills that everyone should know, right? It's a thing that everyone needs to know. But it seems that it's really hard to find a concrete definition of what is creative problem solving. So this is my attempt at doing that. Well, first let's hammer down a few things. An exercise is a task that you already know how to solve. So, for example, if you've seen someone else solve an addition problem and you know how to do like the algorithm, add the numbers, then carry, then add the numbers, then carry, that's an exercise. But a problem is a task where you don't know what to do immediately. And so you need to be creative or clever, and this is where creative problem solving really comes into play. And the goal of creative problem solving is to teach the new and exciting concepts, not the same ones, just in different ways. For example, not new ways to compute 13 plus 37, but rather new unique topics that you might not have seen, problem solving or not. And lots of people do think that creative problem solving comes naturally with multiple skills. And while this may be true to some degree, I think that creative problem solving is itself a skill that needs to be hammered down. And it needs to be especially worked on, and you need to solve specific problems just so you can get the idea of what is creative problem solving. So now let's talk about more specifics to today's lesson, which is on working backwards. So typically when we're given a problem, we can work forwards and backwards, but we always start with working forwards. When we're solving most problems or exercises, we're given a set of conditions. For example, like in a word problem, you may be given like the starting amount of money, for example, just as, an idea. And you're asked to see, like, after a couple of transactions, how much money do you have left? And so that result answer is what I'm going to call a resolution. So you start with conditions and you get a resolution. But in working backwards problems, you're given the resolution and you're asked to work out the starting conditions. So you're asked sort of in a way to do the reverse, but the thing is the problem will never explicitly tell you that it's a working backwards problem. And hopefully this explains the name, right, that it's working backwards. But also it's important to be able to identify when is a problem working backwards and when is it working forwards. Because when you see a working backwards problem, you know that it's really hard to solve forwards, right? Typically in working backwards problems, the forward solution, like the one you quote unquote would use, is a little harder to do, whereas the backward solution is much easier to do and it's much more logical too. So let's take a look at a concrete example of this. So here's an example. The question asks what number goes in the square. So you have a square here. You have plus 3 goes to this circle, times 2 goes to this circle, minus 2 goes to this octagon, which has the number 28. And the question is asking what goes in this square. So you can pause the video now if you want to try it out for yourself. Alright, so there are a couple of ways some students will approach this. I know some people will start by putting some variable in here if you're accustomed to the idea of variables, like putting x here, x plus 3 here, 2x plus 6 here, and 2x plus 4 here, and solving for x. There's a much better solution. Well, I don't want to say better, but it's another solution that I think really hammers down on the idea that we're trying to talk about, which is working backwards. And again, we need to work backwards for this problem. So here's something to get started if you haven't already. If you look at this diagram, what I've done is I've taken what we had before, this black arrow section, and I've reversed the operations on the bottom. Now we have 28, and instead of minus 2, we have plus 2. Instead of times 2, we have divided by 2. Instead of plus 3, we have minus 3. So what I've done is I've taken each of the arrows, reversed the direction and the operation, and now we have this other white arrow path on the bottom. And so now you can see where the idea of working backwards comes in. So again, see if you can pause the video and try and solve the problem. Alright, so hopefully this was enough to get you at least started on a solution. But like it says, this is where working backwards comes in. Now we can start from this side and follow the white arrows to go to the square. And that means that we know what the number in the square is, right? Because for example, if we do 28 plus 2 is 30, we know that the number in this circle is 30 because 30 minus 2 is 28. So you can sort of see that every time we do an operation, to figure out the original number, we sort of take the operation and flip it. So that's what we're doing here. We're taking this negative 2, flipping it to get plus 2, and this goes to 30. We're taking this times 2 and dividing by 2, and this goes to 15, and this is the full picture. So what you can see is the top black line is what we had originally, but now it's filled in. 12 plus 3 is 15, 15 times 2 is 30, and 30 minus 2 is 28. And on the bottom, we have the opposite. 28 plus 2 is 30, 30 divided by 2 is 15, and 15 minus 3 is 12. But you can see that this could be solved, this bottom portion, by working forwards. So you can see, if we reverse the flow in the bottom section, starting from 28, we can just follow the arrows to get 12. And as a reminder, here's the picture. You have this 28, so you can just follow the white arrows and get 12 over here, right? 28 plus 2 is 30, 30 divided by 2 is 15, 15 minus 3 is 12. And this makes the problem much simpler. Instead of trying to reverse engineer the problem, just reverse the problem, and then you can engineer the solution. So let's talk about another example. Here's another example. We are asking that there are some candies in a bowl. Sally took half the candies, and then Tom took half the candies left. In the end, there are 6 candies in the bowl. So how many candies were in the bowl at the beginning? So again, pause this video now. Alright, so hopefully you had some time to try the solution. And if you still need a hint, think about what operation we're doing. In the previous problem, we're doing addition, subtraction, multiplication. So what operation are we doing here? Alright. So every time our operation is dividing by 2, right? We have some number of candies, and Sally took half of them, so we're dividing by 2. Then Tom is taking half the remainder, so we're dividing by 2 again. And there are 6 candies in the end. So this means we reverse it and we multiply by 2. So our answer is 6 times 2 times 2, which is 24. Now you can see that this is a working backwards problem, even though it doesn't look like it. Right? Some people may think this is not really a working backwards problem, but you can see this fits all the criteria. We don't know the initial condition, right? Some candies are in a bowl, but that's what we're being asked. These are the keywords here at the beginning. This tells us that we need to find something at the beginning, and we know what's there in the end. So this is like a telltale sign of a working backwards problem. You don't know what's at the beginning, you have some process, and now you know what's at the end. So here are some takeaways from this lesson. What process are we applying is a good question to think about when you're solving these working backwards type problems, right? What sort of thing are we doing to get the answer? And remember, I talked about the 3 parts again here. Beginning, process, ending. So what is the process we're applying? What operations, what specifically mathematical operations, plus, minus, times, divide. And how can we reverse the process to get the answer? So again, you'll see the most working backwards questions have a start, process, and the end. So to solve the question, you do the end, reverse the process, and you'll get to the start. And here's a final challenge based on these ideas. So you go to a shop and spend half your money and then $10 more. You go to another shop, spend half your money, and then $10 more. You have no more money. So how much money did you have at the start? If you have any ideas for how to solve this question, you can leave your answer in the blog post or in the comments. But other than that, that's pretty much all I have for today. So thank you all for joining me. My name is Arul Kolla. I also make lots of problem-solving games. Currently, my most recent game is called Blocks. You can see at blocks-ak.web.app. But other than that, that's pretty much it. Thank you all for watching. I hope you learned something new about creative problem solving, and I wish you all a nice day. Bye for now.